Hey guys, this will be video 3 no, it's actually video 2 for the how to design build a hollow body 58 Explorer replica, and sometimes using Stuart McDonald templates. And I say video 3, it should have been video 3 because there was such an enormous amount of information that was so invaluable when I was gluing the top down or epoxy gluing the top down, that I wish I had have set up the camera and videoed all that, but I didn't. So I'm going to spend about 5 or 10 minutes talking about the whole order of operations and everything that I was, going through to pull it off and pull it off successfully. And what I'm going to cover in this video after we talk about that is then moving into the direction of, once you get your top routed off and everything cleaned up as far as the footprint goes, then you are ready to start fitting your neck. And obviously, this did not have to be done on the very front end, this little bit of mortise work. But as I mentioned, I intentionally did that mortise work so that it would force me to continually do every bit of this build work from this square and or perpendicular cut here with respect to the center line and that initial mortise cut. Okay, so, and I'm going to make a few corrections, and we'll just talk about the corrections as I go through it. But nonetheless, I'm extremely happy with it. It turned out really, really well. And in case I forget, I was watching the first video, and this glue up line is not showing up nearly as much as I thought it was going to show up. So there's a possibility that I'm going to um, back up and punt and not do binding on the back. I may just round this over, a 1/8 inch round over, and then but only do the binding on the top. And in case I forget, that would be more in keeping with the traditional 50s product from this company, where if you've got a gold top, like a gold top Les Paul, well, it would have one piece of 16th inch binding, or 60 thousandths. So you'd have the gold top, the 60 thousandths inch binding, which is real simple because it's a 1/16th inch route, and atop a mahogany back. And they actually did spray some of those guitars gold all the way around, so it would have been a gold top with cream binding and a gold back. And that's where I was getting at in the first video about this blonde Korina is going to be naturally in the gold and amber family, so that's why I think it'd be really beautiful to do just the single binding. Okay, I got to stop. I'm going to end up doing this video again because I've erased like 3 or 4 of these videos already, and I have actually been talking for like 45 minutes. So I'm about to snap here. If I have to erase this video, it's going to be it's just going to be what it is. Okay, so on that note, gluing the body down. You saw where we were in the first stage, where we had the lower pretty much finished, but I did not have that support, that center support bracing down the middle. I did have to machine off a 1 inch area on the back of that after I found. So in other words, before this top was glued down, I did locate where the three-way would be. And since this is a 1/4 inch thick on the top, and then you've got the thickness of the plastic on the front, it did require that I machine off material from the back. And it was just a matter of taking a 1 inch Forstner bit after I found that location and flipping it over and clamping this down and machining it down until the wood portion became about, probably can't see it, it's about 3/32 of an inch thick. So that was the only machine work that I had to do before I epoxy glued the top down. How did I epoxy glue the top down? When you're working when you're doing this type of a glue up, the primary concern you're going to be or the issues that you would deal with where things really fall apart and go sideways and you lose control is going to be based on too much glue or epoxy and gravity. If you can just consider those two things, you should be fine. So the way I always glue these tops down, and even like if I'm building a chambered Les Paul replica, which most of the Les Paul replicas that I build are always chambered, that means there's a lot of cavities within that body that once that top gets glued down, I'll never have access to it again in order to clean it up or get it under control. Whereas like you might, let me see if I can get this in the camera. Okay, I didn't want to talk into the camera, but basically down here, that was the only area that I was able to reach in and do any cleanup. And because I did such a good job at putting the minimal amount of epoxy down only on the lower portion of the body, I had very minimal cleanup right there. And also, when I did this route work here and here, it I can reach up in here and I can feel down beside either little block. See, that's the end of the block. That would be the end of the little block that was in there for the ABR1 and the tailpiece anchors. So there's no excessive squeeze out when I reach down in here. So I did a really good job of putting the epoxy down. And also the reason I don't feel anything is because after I did all of the glue up and the clamping, I flipped this entire body over and let gravity work to my advantage so that if there was any spillover, which I'm sure there was probably a little bit in there, if anything, it's going to pancake out around wherever it is. But based on what I saw when I opened that up, I realized that I had a really good amount of glue in there. And if I say glue, I'm always talking about epoxy. Let me check the time. Okay, 7 minutes. I'm just gonna go with it. I hope it's not a bad video. If it is, I apologize. But there's so much information here that it's difficult to determine what I should talk about or should not talk about, and even consider, whether anyone's ever even going to attempt to do anything like this because it's an enormous it's an enormous amount of time to pull something like this off. Okay, so on that note, we discussed gravity and glue. So we got this body here, and this top is laid over here dry, where the only thing that has happened, it is machined on the back. It has not been sealed on the back yet, and this is why I should have done a video too. So you've got this top that you're getting ready to epoxy glue down, but it's dry as a bone. But somehow or another, you've got to seal it. You can't leave that raw wood in there, or this thing will always be a nightmare as far as expansion and contraction. And so how you pull that off is you've got your epoxy mixed up, and you come in basically with your bamboo skewers, and you're just feeding a little bit of epoxy all the way down, and then you're kind of working it in. You're having to work with a 24-hour epoxy, so you've got plenty of work time. Because after you get all of this epoxy atop all of these surfaces, then you're going to have to assess the mill thicknesses of every bit of the work that you did. I've done this so many times, I know exactly how much mill thickness I can get away with, because you'd be shocked at how little amount of epoxy it takes to glue these things down. The biggest mistake most people make is they put too much glue or epoxy in there. And if you were to try to glue all that down with Titebond, oh man, if you were going to use a Titebond, it would have to be placed down, clamped, and flipped over and just left alone, because you cannot access any of this up in here to clean it up. You can't even see it. So, not being dramatic there, but just keep that in mind. If you're building something like this or a chambered guitar, it's got to be an accurate mill thickness. So the great thing about working with a 24-hour cure time epoxy, you've got all this epoxy down on the lower. Then you take your top, and I did fail to mention, I did drill I did drill a little 16th inch locator hole through the top and through the body, clamped up dry. so that when I put this top down, all I had to do was just allow that little 16th inch nail to align this area up here. And then I did have my little tenon here that I was able to fit and align and kind of assure I kept water on this so that it wouldn't risk glue into it, and that assured that this stayed clean up here. And then all I was having to worry about aligning was this location right here, which, if you remember, I had a piece of tape over here with a mark on it for the center line. And then once I had all this clamp work up here and blocking, and it probably weighed close to 60 pounds after it was all said and done, because I had these massive poplar blocks on the top, poplar blocks on the back, big poplar block here, and then all these clamps going around here, cabinet clamps where I can kind of use them like a caliper and dial into them and not overstress it, because it's real important that you clamp this with very even force. I had like 2 foot levels running down this direction right here. These were the first 2 locations that got clamped temporarily, and then in other words, that location and that location. And then I just reached up here by hand and squeezed this together, then removed all of this stuff. And then this is what I meant by I wish I had done video too. Then after I removed those clamps, I removed the top and I assessed the transfer of all the epoxy that was on the lower onto the upper. And then I was able to make a determination of, okay, yeah, I got too much over here. I got to clean this off and redistribute all that, et cetera, et cetera. I was a little bit dry right in here. I was a little bit dry over in here, which, if anything, that's a good thing, because it kept me from having way too much excess epoxy on the back side of the top. I repeated the process, pushed it down again using the nail access and the center line down here, made sure everything was good, and then I did a little bit more clamping force on the outside, and immediately removed the clamps again and immediately removed the top a second time. Okay, so you could not do this with Titebond. You'd end up being a rubber gasket. It would never glue properly. And for transference of tone. And then that's when I realized, oh yeah, this baby, she's ready to go together. So once I had that marking on the backside, then I took a brush with nitrocellulose lacquer, and I came in, and wherever I did not see epoxy, I sealed it with that brush. Okay, and then as soon as I sealed it, and it was it's not running, but you don't, actually put some epoxy on there and let it really kind of saturate into the wood. And then as soon as I did that one coat of the nitrocellulose lacquer and all the dry spots, then the whole top, you could not tell where it was epoxy and where it was nitrocellulose lacquer, because the epoxy was so thin that I knew this baby is ready to be finished. And also, if there was any run over on the lower, because of gravity, if I had way too much over here, then it would have been running down the side of one of those blocks. And if that were the case, then I cleaned it up with lacquer thinner or something like that. And then on that third time's charm, when I put that top down that time, I knew beyond a shadow of a doubt I was ready to do all the clamp work and just finish the job. But the only thing I was concerned about, I knew that because I was getting ready to do all this clamping force, there was probably going to be somewhere in there was going to be a little cricket where there was a little bit too much epoxy, and it's just going to be a mystery. So I did all the clamp work, all the clamps, anything that's long in the clamps, because some of my cabinet clamps are probably 18 to 20 inches long. I made certain that every one of them were standing up this way. Okay, and then that way, once I did all this clamp work and did have a substantial, not a substantial, but a very good squeeze out all around the body, That's where I was coming in with this blade right here and cleaning that epoxy off and just, discarding it. And then the last thing I did was, I just did that enough. And see, it's still, gravity is against me, working against me right now. Because if there's any massive squeeze out in there, it's running down the side. So I didn't spend too much I didn't spend any major time cleaning this out unless I had a massive runaway out here. I got this thing turned over as quickly as I could, and and then I stand them up on my floor, and it looks like a coffee table. Okay, now at that point, now gravity is working to my advantage, and any bit of squeeze out that might be in there, it's just kind of settling in and kind of flaring out on the sides. But if you, I'm going to try to show this. Okay, that should have shown how clean it was in there. In other words, there's no massive amount of epoxy squeeze out. And also a real telltale sign, because this had not been machined yet until the next day. So if there was any massive squeeze out, I would have been able to reach up in here and feel it down and around that blocking. Wherever I can reach in with my finger, uh, fortunately, I don't feel any squeeze out at all. Quite frankly, I don't feel any squeeze out. And that's, you might think, well, then you might have dry spots in there. No, you're guaranteed that you don't have dry spots because your 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 imprint that you made revealed to you that there's a chemical transfer from this lower to this upper part. Then you can rest assured knowing that you don't have any dry spots in there. Okay, and that's what I meant by, damn, I should have done a video too, because that was really a disservice to you guys that are really serious about doing something like this. But it just is what it is. But just think through your project and use gravity to your advantage as quickly as you can. But also use the epoxy to your advantage by doing the imprint, removing it, assessing everything, putting it back down after you clean it up a little bit, remove it. And once you know you got a good project or a good surface contact, then seal whatever's not sealed, and then finish the body. Okay, it can be really stressful if you don't really think through all those order of operations, but it can also be extremely rewarding when you build something as absolutely complex as this. And this is a very complex build. So, and also, and that's just with my finger. I mean, if I came in with, I don't know, might come in with, this might be a little bit too loud, so I'll tone it down. Try to find the bass line. All right, let's just do a tap tone real quick. Okay, that's the perimeter. Here's the center block. And all of a sudden it's going to get real chintzy right here, because there's nothing under it. It's the same as right up here. It's kind of chintzy out in here because there isn't any support under it. But let's go down this tone bar for the treble side. That's incredible. That's awesome. That's your target. You did not lose the tone at all. You didn't lose the tap tone, even though you went all the way down this body, and even though those tone bars are floating. And one thing I didn't discuss in video one, just because of the natural design of this body, this base side tone bar is longer, deeper, and more resonant, and there's more area up here than the treble side tone bar. It's almost a brilliant, unintentional mistake that took place to keep higher pitch, notes along the treble side, and then deeper, richer tones on the bass side. Because if you remember, I didn't mention this in video one, but those two little blocks down here, I intentionally kept them separate because I wanted to define the treble side contact of the bridge and anchor tailpiece to the body. I wanted to separate it from the bass side, primarily just out of curiosity of what would happen. Okay, and it worked. Sounds great, incredible. Okay, so we talked about gravity and glue. We talked about all the operations that you go through to get that glued up. Your top is a little bit large. I don't care if I'm redundant because I've done this video so many times. I did drill a 1/16 of an inch hole through the top here in this corner before this was machined out. And so that I had an alignment point there when I put the top down each time. Because, yeah, think about that. Because you got all this epoxy on here. You can't be removing this top and putting it back down multiple times unless you're going perfectly straight down and not off. So that's what I meant by I've got the 16th inch nail pin up here as I position the top. Then I'll let the back go down, watching that center line right there. And then once it all glues together, when I start doing all that major clamping force, all I have to do is have my tenon in there, and that guarantees that it doesn't travel up here. And then all I'm doing is just watching this center line back here as I'm beginning to do all this major intentional clamping force. I think I've already covered this, but obviously I'm running a 2-foot level down here, and I'm running a 2-foot level right there. And then on whatever's remaining, I've got actual poplar blocks that are intentionally designed for doing glue up. And I have a poplar block there that's pretty much that dimension, front and the back. Then I'm able to use my cabinet clamps and start bringing everything together. So the entire outer perimeter outside of the 2-foot level, or the 2-foot levels, is all massive block work and cabinet clamps. Okay, so gravity and glue, weight correction. We'll talk about weight here in a little while, but I was a pound too heavy in my assessment. The whole three pound thing. Body construction correction. Okay, let me check the time. All right, awesome. 22 minutes. I hope I don't sound nervous or anything, but I'm just trying to get a ton of information in this first portion of this video for those of you guys out there that are really considering pulling the trigger on something like this, because as I mentioned in all the other videos, this is a really complex build. But if you just think through it and make certain that you're working with chemicals that give you plenty of work time, you'll be fine. And it'll be very rewarding once it goes together, because those tap tones are just, that's beautiful. It's off the charts, man. Again, this is not a guitar that you would, design for use with a Marshall stack, a 100-watt Marshall stack. But I've never even played through a Marshall stack, and I don't even know anybody that owns a Marshall stack. So I think those arena days are kind of really behind us. I think this would be an awesome guitar to, you could use it direct. And all the incredible electronics and the gadgets that they have out there now for creating, tones and sound, you really don't even need amplifiers anymore. But on that note, this body will react unbelievably with an authentic tube amp, is what I meant when I was talking about this thing would be incredible with a Tweed Deluxe or a little Champ, or just anything with tubes in it. I used to own a little amp called the Gibson GA15, GA15. It's actually a Trace Elliott design. That's one of the sweetest little amps I had ever played, and it was only a 15 watt. And that was when I got my first taste of, wow, you don't need 40 or 60 or 100 watts to get a beautiful, and even it was loud too. So anyway, this guitar and this design, creating all this natural color as like an acoustic is going to be really sweet through whether it's acoustic or amplified. Okay. All right, let me check the time again. 25 minutes. What should I talk about? What the only correction I need to make as far as the body construction in this video will be, I had mentioned building everything around this mortise and tenons configuration, this block, and that is true, but that's not the very first thing I did, because I got thinking, I watched that video again, I was like, that's not what I did. The first thing I did was like a year and a half ago. I glued these two pieces together because I thought, if anything, I'm going to build a mahogany lower that's 1 and 7/16 inch thick, and then I'm just going to glue this down to the top of that and make a really beautiful topped guitar. And then the more I looked at it, I was like, man, I've got all this extra scrap blocking, and I know how to build a chambered guitar versus a hollow body, and then how to do a hybrid design. So after I glued these two pieces up, they ended up sitting on my shelf over here for a good year and a half. And I just would come in and look at them every now and then. And then if I got a little bit of extra time, the first thing I actually started doing was all the layout and assessment of, yeah, that's definitely, that location right there, that material right there. And then this location is definitely perfect for that. But I did do, there's a glue line right here. There's a glue line right there. There's a glue line right there where it has a little cap on it, a little end cap. And then there's the glue line right there. I don't even want to show them. Okay, there's a glue line right here where that piece went in. I'll show this butcher block bottom, but that's just all the wood I had left. But I knew that the way the end grain orientation was, as you're moving around, and obviously the guitar's down, you'd have to be on a really high stage for someone to look up and see anything that's ugly down there. And also, nobody cares, you know. But I was watching that video and I noticed right now it's showing real dark because of the end grain, and the end grain orientation of this wood is very different from that. But it's the best I could do, because I noticed that once you turn this way, it kind of vanished a little bit. So I was gluing up all these component pieces like 1 or 2 hours a night after I finished something else, or while I was waiting on something to dry. Well, I'd grab some of these little blocks up and do some machine work and then stick them over in the corner. And I was doing all of that glue up atop my table saw because it's a perfectly flat surface, because I knew at a minimum I got to keep everything true because I'm building it in component form. And then after about 6 months, 8 months of slowly doing this perimeter, okay, I apologize for this being such a long, drawn-out conversation, but basically what happened was this upper bout configuration was all finished, and then it was glued to that center block. This area over here was finished up to like right here, okay? Then it was glued to that center block. This end was finished because I knew it was very important that it looked like a solid guitar, and I was very happy with that. And then I started fitting these pieces in. And then what you had this shell, just like a hollow body guitar, where the outer perimeter is finished. You have a neck block. It was thick enough that it did not need a tail block. So after I had that outer shell finished, I knew it was time to glue the back on it. And when you glue the back down, but before I could glue the back down, I had to do every bit of that rib work in there, and I think that was another month or two, if not 3 months. So it's been going for a long time, but you saw how quickly the top went on. Okay, so again, if you're this far into this video, you're really serious about, and you're really intrigued by possibly doing something like this. And there was only one guy that commented in the last video. I don't think he was being a smartass or anything. He made a statement that I lost him after Ted Nugent. And what I meant by Ted Nugent was, most of us older guys, we know that Ted Nugent was always, he played the hollow body a lot. I think he played the Gibson Birdland. And he and Brian Setzer were, to my knowledge, only the two players from the 70s and 80s. I know there were other guys back in the 50s and whatnot, but they were playing loud. And Ted Nugent was the only guy that I've ever seen that was able to take a hollow body and run it through extremely high powered amps and keep it under control. And that's what I meant by, if there was ever a time to call Ted Nugent, hell, this is the guitar that he probably, this should be the Ted Nugent signature. That's what we should call it. So if any guys out there know Ted Nugent, let him know, maybe this is something that Gibson should build for him. So that's what I meant by, if there was ever time to call Ted Nugent, because this thing would be a train wreck monster as far as going through a high powered amp. And a guy like Ted Nugent knows the importance of the master volume. And on that note, you might even, if you were going to play it through an amps like that, you might even want to add or either have this turned into just a master volume like the Birdland or the Gretsch 6120. And if any of you guys have ever watched Brian Setzer, he's continually reaching down and controlling that guitar with the master volume. Same thing with Ted Nugent on the Birdland. There's a master volume switch there, pretty certain, because I'm pretty sure it has a three-way up here like a 6120. But if you wanted to, you could do the three-way right here, a master volume here, and then just do whatever you wanted back here. So I'm going to keep it very traditional just because I want it to be a traditional design, but it could be changed. Okay. So if that answers your question, whoever you were that commented and made that statement, that's why I mentioned Brian Setzer and Ted Nugent, because they were the only two artists from my era that I knew of that played wild rock and roll through hollow body guitars. Okay, next time. 32 minutes exactly. All right, let's do some weight analysis, because we talked about, let me just look at my notes here. Gravity and glue, weight correction. Yeah, we're about to do the weight analysis. And then I did talk about the body construction correction, and we're going to talk about weight analysis right now. So let's get the scale back up on the table. And then if there's any time left in this video, I'll talk about neck construction a little bit. That should be in the camera. So, what does she weigh? I have no idea, but let's check it out. Sorry, let me tear, make certain that it's cleared. Let's start with pounds first. 3.926 pounds. 1,781 grams. She's light as a feather. And the mistake I made was the whole 3-pound assessment. The short is this. Your neck, whatever your total guitar weighs, you could subtract. Let's say your target was 8 pounds. Then you subtract 3 pounds, and that's what your body can weigh. So that's your formula. If you had a target of 8 pounds, you subtract 3 pounds for all the electronics and the heavy stuff, including the neck, finished. Frets in it, fretboard on it, tuners on it. That's all of the, in other words, the 3 pound included the neck. So what am I saying here? I'm gonna have a 7 pound guitar. This is just going to be, it may even be under 7 pounds. So that's, and see, that's what you want for a hollow body. You don't want a 9 pound hollow body guitar. That you really didn't achieve anything. But if I'm going to be able to build a 6.9 or a 6.8 or a just over 7 pound guitar, and it's a full size footprint like that, and but it's got all the appointments of the Gibson design, the 2 humbuckers and all that rock and roll wiring and jazz, that's going to be a screaming guitar. Okay, so getting back to, let's see if I can just do this. We'll just start loading it up. No, I tell you what I'll do. I apologize. I should have been a little bit more accurate here. Let me get the. So we're just going to start loading her up. All right. I have a complete wiring harness that I designed and built for my 6120. I have two potentiometers down here for volume and volume. There's an output jack, switchcraft. Then up here, I have a three-way, and I also have my tone control up top, and then that's my master volume. So, in other words, I've got a very similar wiring harness here. It's almost identical because I have three potentiometers for everything. I've got actually one potentiometer too much, so should be very accurate. And this should be a really accurate assessment of what all these parts are going to weigh. Okay, let's keep going. There's our pick guards. We're up to 1.190 pounds. Here are our two anchors. Those are some pretty serious weight, so you want to make certain that you get those in there. And then a Clouson aluminum tailpiece, Clouson ABR1 bridge. I should have already. Do this. This thing will turn off fairly quickly. So let's get our Clouson USA tuners up here. And I'm having to do this kind of fast because the scale they'll shut down fairly quickly. Okay, here's our press-in ferrules. All right, right now we're at 1.854 pounds, 841 grams. What else? Bone nut. Wouldn't recommend a brass nut on this, although I do build a lot of guitars with brass nuts, and I just love the tone of a brass nut. 1.904 pounds. 863 grams. 1.904 pounds pickguard screws plus the cardboard should be it. So roughly 1.932 pounds for all of the electronics. Now, if you did a Bigsby, add that weight. But if you did the Bigsby, then you're obviously going to deduct the tailpiece. Okay, so 1.932 pounds. So let's just say 2 pounds by the time you spray the nitrocellulose lacquer. And that's being a little bit conservative because that lacquer can build up some substantial weight. The only thing I failed to put in there was the truss cover, but since I got that piece of cardboard in there, I'm probably getting pretty accurate on covering myself there. Okay, so now this still does not include the neck. So and see how quickly it cut off. So it was 1.93 pounds or something like that. Now let's just do a rough assessment of the neck. And then, so we know that if we're 4 pounds here, 5 pounds, 6 pounds for all that stuff, whatever our neck and fretboard may weigh. Oh, I don't have a truss rod. Okay, this neck is obviously not finished, but we can get a fairly good assessment here, knowing that we're going to be rounding off a substantial amount of material. It's a lightweight material, though. If you had a real dense board and the volume that you take off, then it's going to be a fairly drastic change, or it's going to be a fairly drastic reduction in the weight. But since this stuff is so light, you can take a fair amount of wood off, and it doesn't really make a huge difference. It makes a difference, but not a huge difference. So if I've got a Oblivion rosewood fretboard, a truss rod, and then a whole bunch of frets that haven't even been fit and cut, then we should be fairly close to assess. Plus, I haven't cut out that location. So let's see what a fretboard would weigh, or a neck would weigh. And we should have a very accurate assessment of what this thing's going to weigh when it's finished. And then I'm going to stop talking. Okay, 1.736 pounds. It's a little bit more than I thought it was going to be. Yeah, I always remember now it's 1.5 pounds. So what does that equate to? 4, 5, 6, 7.7 pounds. Worst case scenario, this guitar is going to weigh about 7.75 pounds. That's a great target. In reality, after it's all said and done and this stuff is shaped, these frets are, in other words, it's finished, it should weigh about 7.5 pounds. And that, to me, that's an exciting target to achieve with such a large footprint. Okay. All right. I'm going to pause and get all this crap off the table and then figure out how to end this video. Okay, let's dive back in. I've been paused for close to 45 minutes. I had to get a bite to eat. So gave me plenty of time to think about how to finish this video. And I'm really thankful that we're only at like 42 minutes. So let's talk about a few more things before we get to a point of no return. And to me, what would be a point of no return? It would be once you have your neck built and your neck is positioned to go in here and flush out at a certain height and things like that. That's when you would really need to finish the guitar as you originally had planned. But let's say you didn't have this really beautiful wood right here, even though I'm planning on painting it a color. If you just didn't have this material here and you had to build that top up out of something like a really thin maple or some mahogany, you could glue up a whole bunch of different pieces of wood. And I'm not saying that this is the way you should build every guitar. I'm just saying that, as I said in video one, us woodworkers, we don't throw anything away. But if I've got a box full of Korina or beautiful Honduran mahogany over there that I know is quarter sewn, I don't want to chop that up and use it as blocks when I know that I could epoxy it together. So if you had some scrap material, if you glued it up or epoxied it together, but you knew it was going to be unsightly, but sound incredible, well, then you could come in with like drum wrap material and go the whole Gretsch route and do a sparkle top. And I've got numerous videos in the past where I've built sparkle top flying V's. I don't believe I've built any other sparkle top guitars in video series, but I have restored guitars and done a lot of sparkles. In other words, I've done a lot of sparkle work. And this is just a Delmar drum wrap. This is really old stuff. This is from the 60s. Bought this off a guy out of California. Actually, it was his estate, and they were selling a whole bunch of vintage stuff from the 50s, 60s, and 70s. but you can still buy this stuff. It's just Delmar, Delmar drum wrap, and you can get anything you want. Black, blue. You can get glass sparkle. This is foil. It's not the glass. But anyway, so you can do a sparkle top and a binding. Let's see if I can get this on the camera. I won't be able to hold it because this thing is warped really bad. But this will give you an idea of since you haven't installed your neck yet, you know, you contact cement this stuff down, and it's really simple. You just brush or roll on with a foam roller the uh, contact cement, and I would recommend sealing it first with a nitrocellulose lacquer so the contact cement does not sink down into the wood grain. But have a really good foundation there, and then put your contact cement down here, and then roll one coat of contact cement here. Wait about 30 to 45 minutes, and then once it goes down, you got a J roller that you roll every bit of this out, and you've got a finished top within 45 minutes. And I got to tell you, I love doing sparkle top guitars because it saves me a ton of finish work in the future. And then after it's on, then you just come in and route it back that 1/16 of an inch and do your binding, and you got a beautiful guitar. And one that's like no other out there. So that's if you just want us to really shock the audience with something crazy. And I think Steve Stevens has a red sparkle Les Paul replica that he's playing, and he mentioned that's his favorite guitar. So let's talk about fitting a neck. And let me check the time. I'll probably spend 15 or 20 minutes talking about this, or possibly, let me get a drink of water. Hold on one second. The reason I brought up that point of no return, sparkle top, et cetera, is because any little bit of thickness you add to this top, you have to, it'll change everything. So according to if that's the top of the neck that's being glued in, if you add, a 1/16 of an inch, well, then it'll affect everything all the way down to the actual finish height that goes on right here at the bridge. So plan your work your plan, as they say. But when you're at this point and you're ready to install a neck, or at least go ahead and do this finished machine work right here to a certain depth, because see, you're going to have to taper that bottom, whatever pitch you elect to use. And I would recommend going about probably about a 2-degree pitch max. You could go 2-degree pitch if you allow this neck to just barely drop below the surface on this corner right here, because if I say anything from here on out, this plane right here and where it hits this corner and where this neck goes in, that's the whole guitar. It defines everything. And if you did too steep of a pitch, let's say you went with like a 3-degree pitch, it ain't gonna work. Your bridge is going to be so insanely high, it's going to be crazy. But if you go with a 1.5-degree pitch, well, you might get in trouble, and your bridge might end up being pretty much right on the bottom, and then you're in trouble. You're in more so trouble either way. If you get it too high or get it too low, you're in trouble. Just do a lot of engineering and try to hit the target to where the string height or the height of that saddle, the top of that saddle, in other words, the bottom of the string, from the top of the guitar to the bottom of the string or the top of that saddle, you want it to be about right at 11/16 of an inch max. I like them to be around 5/8 to 11. I like the 11/16 because I'm so used to playing the Gretsch with the Bigsby stuff and everything's real high. But some guys, like if you're a Strat player primarily, if you go over 5/8 of an inch height or 11/16 height at this location right here, it's going to start feeling pretty tall, especially if you build a guitar that does not have a pick guard. But you'll be surprised if you do. Well, I'm not going to start talking about hypotheticals, but by doing the 11/16 of an inch maximum height, the thickness of the pick guard is still going to make it feel a little bit more lower profile. Okay, we'll stop talking about that. But just you, if anything, just by me making that statement, you should consider it should make perfect sense that okay, well that makes sense as long as I keep this around 5/8 of an inch to 11/16 at that location. Once it's a plain guitar, then it should feel like this product. Okay, but the next thing you would want to do before you do much more finish work, if this is your guitar and you're going to paint it, then we know that this is our finish. This is our finished plane that we will be building everything from. And I just know that once my neck goes in and my traditional fretboard thickness goes in with traditional fret heights, that's going to and if I go in at just under 2-degree pitch, then I know that I'm going to achieve that bridge height. Okay. So on that note, the only thing that's important now is to make certain that before I spend too much more time doing any finish work, is just centering the neck of my choice into the body. And if you have the STMAC templates, then let me get a grip on it here. If you have the STMAC 1959 Les Paul templates, do a flyby here. And if you see that score line, that's the 16th fret location because that's for a Les Paul. That's inaccurate for this build because we're connecting the body at the 19th fret location. But all I'm doing now is using this tenon to assess the center line. I'm hitting everything here, sorry. I'm just using this template to assess all of my machine work. And I'm spot on. Okay, so, but if you don't have this nice little template right here, you can simply do something like this right here. If you want to know the truth, this is quite frankly easier and more trustworthy. All you got to do now, because we know that tenon is straight, let me find a straight edge. Yeah. Let me pause. This is really important. I can't find my straight edge. Okay. And again, all we're doing here is just assessing the machine work to the true center line of the body, which is defined by where the top was glued down. And that's what I meant in the first video. If you got to have a center line, especially for this guitar, because everything's so straight and true that if you get off just in the slightest, everything's going to start getting exponential. So one way to assess is the machine work true, and can I just pick up a neck that is finished and ready to go in? To glue it in is simply by doing this right here. Put your little template in there, put your straight edge on the top, come up here, and with a real sharp mechanical pencil, like a 5/1000 or was it Ponos? Whatever, the real fine mechanical pencil, draw a line here, go to this side, draw a line on that inside, and then I found it's easier to just put a number like 3 or 4 directly on the actual center line of the guitar, and then look over to the left and and assess whether it's the same distance out to the pencil line that was drawn. If it is off, which it probably will be off if you've never done this before, then you just start making the determination of how to correct this back here. And if you're off like a 16th of an inch, that's considerable. And that's roughly like a millimeter. That's considerable because you'll end up, it's just, that's considerable. You can be about a 64th of an inch off, and that's not a big deal. That'll work out in the end of the guitar build. But if you've got some serious issues here, then you screwed up on the front end in your initial build, and you don't want to do that because once you start, here's what's going to happen. If you now start changing this direction, I'll exaggerate. If you were really high, and now you start machining this out, well, now it's going to change this plane here. Now you're beginning to chase all these different things that are going on that should have been defined on the very front end. And that's what I meant by I built this whole guitar from that machine work. not beating a dead horse, but just because I knew I'd rather do really precision machine work on the front end rather than proving how good I am at correcting a bunch of screw up mistakes. And I don't want to do that, because when you're trying to correct all of these mistakes out here, you're literally correcting 7 different points. 1 point here, 1 point here. Let's see, 1, 2, 3, 4, 5, 6, 7. Think about that. It's not just a straight block going in. It is a arched. I should have shown it on this right here. You got to connect everybody. You got to connect everybody to these 7 points. This line right here. 1, 2, 3, 4, 5, 6, and then the depth. Why the depth? Because if you don't bottom out, it's better for this to be a little bit too short, because that guarantees that you're bottoming out really well. Okay, that's where I'm going with this. So when it really comes down to it, you're working with all these different. See how beautiful that fit is right there, and that's just rough. But once you know that you're that close, it's going to go together really easily. And then you make the determination as to how much more work you do on the body. I do have to do the binding work because I want the binding to be done before I try to fit this. But trust me, I'm really just skimming the surface here about fitting the neck to the body. But that's what you're going to be doing. Okay, now if you didn't have a template like that, or you wanted to, but let's say you already had this neck work right here, you can also put this in, as that. It doesn't have to be married up or anything. But what we've done now is we can now take a straight edge and assess the trapezoidal path. Okay, so we know that since this neck that's in here is tapered, okay, we can assess the trapezoidal path along the treble side, make a mark down here, put some masking tape across that, make a pencil mark there, and then move this straight edge over to this side, make a mark right there. And I'll shoot really straight with it. This is exactly how I always do it. I never do just this. So I might do this for initial assessment just to make certain that I didn't screw something up. But this is how I do it, because I know my neck is finished. I know my tendon to neck central line is always perfect. So it's more trustworthy than what's going on in the body. And if I make any changes, I'm going to change the body a little bit. Because once you make the mark over here and the mark over there, then you do the same thing where you just measure off of the center line and assess them for consistency. Okay? And I've covered this numerous times in all the past builds, but it's one of those things that I wouldn't even know where to send you and which video to show you how I explain that. And there were times in certain videos, man, I spent 45 minutes talking about roll, pitch, yaw, and all that stuff. And I'm not going to start talking about that right here, but we all know that the neck has to be true. And it has to be true like this, and it has to be true like this. That's called the yaw, and it has to be true like this in the pitch. So just briefly approaching it, roll, pitch, and yaw, Y-A-W. Okay, it's just like flying an airplane. And I've said that so many times, I'm sick of hearing myself say that. So let me check the time. I'll probably end the video right there. 58 minutes. Yeah, that'll be awesome if we can get out of this class for under 1 hour, because this is some mind-numbing information that I went through here. Again, this should be video number 3. And it would have been so much easier to have done this video if I had just shown that build process in video 2 and chasing that epoxy and sealing the internal parts that were dry and all that jazz. But really happy with it. At this point, when you're getting ready to make assessments based on the templates, as I had mentioned, I had already defined this point right here. These 2 points right here are the guitar. That's the 19th fret location. That's the center of the scale, 24 3/4, or maybe yours is 25. And once you have that, one way to assess this neck to body join and center line assessment is something like this right here. Use your little pieces as cheaters. Let me just do it. Stop talking. And then you can come in with a pencil and you can just reach down there and just draw the circle. I wouldn't recommend drilling these yet